In the small hamlet of Bourbon, 25% of the houses are villas, while the rest are simple bungalow houses. 35% of the houses have central air conditioning installed, while 5% of the houses are villas without central AC. What is the probability that a randomly chosen house will be a bungalow that has central air conditioning? Okay, so it's a word problem. We might first try and recognize the events that we're talking about. Okay. We're interested in bungalows. We also have villas mentioned, but we can see from an earlier statement that if it's not a villa, it's a bungalow. So if it's not a bungalow, it's got to be a villa. So we really only need one event to represent these. We might say B is the event, a randomly chosen house is one of those simple bungalows. Okay. And so then, if you're in B complement, if you've randomly picked a house and it's not a bungalow, it must be a villa. Okay. So that way we can more easily make sense of the question, and we're not adding in extra events that are allowing us to miss connections. We can see this connection quite nicely now. Alright, so that's a good event, but then they also talk about air conditioning. So we'll have the event, a house has air conditioning. We'll just say AC, so we don't have to write it out. Central AC specifically. But maybe they have those air conditioners you can put in the window, but we're talking central AC here. Okay. Having named some events, we can go back through the language of the question and see what we can pick out. For example, they said 25% are villas. Okay. 25% can be changed into a probability. Okay. So the probability that we find a villa is 0.25. Okay. They also talk about the probability of having air conditioning, which is 35%. So we can convert that as well, divide by 100, move the decimal place to the left 2 points. Okay. And then it's a 5% probability that you've got, I think it was a villa, villas without central AC. So that's B complement, and there's no air conditioning. And what do we want? We want the probability that we've got a bungalow that happens to also have air conditioning. Right? Just go back and quickly double check. Randomly chosen house will be a bungalow with central air conditioning. Alright, so this is our task. Find the probability of B intersect A. What can we do here? Well, first thing I can think to do, we know that 0.25 is the probability of B complement. But the way we calculate probabilities is 1 minus the original. Okay? So 0.25 is 1 minus the probability of B. If I add the probability of B to both sides, and I subtract 0.25 from both sides, okay, I can see the probability of finding a bungalow. It's 75. 3/4 of the houses here are bungalows. Okay, that gives me the probability for B. Something else we might notice is we've got not having a bungalow, that is having a villa, and not having air conditioning was 0.05. Okay. But we can rewrite this a little bit. Okay. We could write this, okay, instead of saying A complement intersect B complement, we could say A union B complement. That's our beloved De Morgan's laws at work. And so the probability of A union B is just going to be 1 minus this probability. And we can get 0.95 without too much trouble. Okay. Now we want the probability of having air conditioning and it also being a bungalow. So that's the probability of A plus the probability of B minus the probability of A union B. And we just figured out all of these values. So it's 0.35 to have air conditioning, 0.75 to have a bungalow, and 0.95 to have air conditioning or a bungalow or both. So 0.35 and 0.75, 0.3 and 0.7 would be 1. The two 0.05s would give us 1.1. Okay. And if we were to subtract 0.9 from that, we'd get 0.2. Subtract an additional 0.05, we get 0.15. Okay, so the probability that we get air conditioning and a bungalow, it's going to be 15% of all the homes in this town. Okay. Now that was not the only way we could do the question. Okay, let me show you a different way. Okay, so we'll start again with the information we know. It's always a good idea to be able to have different ways, different approaches to questions. That way you're not doing the same thing over and over and over again. You're learning, you're adapting, you're applying. This was 0.05, if I recall correctly. Okay. So the first thing I might do here is say, well, we know the probability of not having a bungalow is 0.25. I can rewrite that as the sum of two probabilities. Having air conditioning and a villa, that is not a bungalow, and not having air conditioning and not having a bungalow. Okay. Now how can I do that? How am I allowed to do that? All the sample points in B complement, all the houses that are not bungalows, are either not bungalows and have air conditioning, or not bungalows and don't have air conditioning. Okay, so it's a nice even split. This allows us to add up the probabilities because they're distinct sample points in each, but all the sample points of B complement are represented. Okay. And then we do a little bit of work and we see the probability of having air conditioning and a villa, be your chosen house, your randomly selected house, is 0.2. Okay, how does that help? Well, what do we want? We want the probability of A and B. A intersect B. Well, we know the probability of A, getting air conditioning, is 0.35. Using the same trick, okay, the same sort of breakdown, we can write this as the probability of having a house that is a bungalow and air conditioned, plus the probability of having a house that is air conditioned and having it not be a bungalow. And we just worked out that probability. Okay, we just saw that that was 0.2. Okay, so now if we, oops, I've already jumped ahead in my calculations. So 3.5 over here. So now if we subtract 0.2 on both sides, we get the 0.15. Okay. So we worked out in sort of two very different ways, using De Morgan's laws, rewriting using some formulas from the definition of what a probability measure is, okay, or breaking it down with collections of sample points. Okay, but either way, we get 0.15 or 15%.